right, so we're going to be looking at two uses of simplifying radicals, the Pythagorean theorem and the distance formula. And actually, the two are very closely related. So hopefully you remember seeing at least a little bit about the Pythagorean theorem in the past. The Pythagorean theorem is used specifically for right triangles. And what it says is that the sum of the squares of the legs equals the square of the length of the square of the length of the hypotenuse. In words, it looks a lot messier than it does in actuality. So the legs of your triangle, your right triangle, are the sides that are directly next to the right angle. So here's your right angle. The hypotenuse, if you make your right angle a little arrow here, the hypotenuse is that longest side. It's the side across from the right angle. So when we label the legs and the hypotenuse for Pythagorean theorem, we use the letters A, B, and C, the C always being the hypotenuse. The A and B, it doesn't matter which one is which. So what the Pythagorean theorem says is that the two legs, if you square those values and you add them together, it's equal to that hypotenuse squared. So what that allows us to do is actually allows us to find missing information on right triangles only. There are other ways to find information, missing information, side lengths or angle measurements, but you would have to use trigonometry, which you'll see in geometry class. So the Pythagorean theorem says, again, I've got a right triangle, check, that's a good thing, I've got a right angle there. So it says that a squared plus b squared equals c squared. So again, a and b are the legs, it doesn't matter which one is which, and c is my hypotenuse. So having those values lets me plug this into, this theorem is a formula, it lets me plug in 3 is A, 6 is B, and I don't know what that third side is. So if I square, if I follow our order of operations and solving here, I want to get C all alone. But first I want to figure out what number this is. So 3 squared is 9, 6 squared is 36, still equal to C squared. 9 and 36 gives me 45. Now I just want to think, okay, how do I get C alone? What's the opposite here? Well, the opposite would be if I took the square root of both sides. So hopefully you see now, and we're finding C, was not meant to be a pun, but hopefully you see now, okay, we have a square root that we don't know and that it's not going to be a perfect square. So what we need to do, what you're looking for is these answers in simplest radical form, which you'll do this a lot more when it comes to when you're in geometry next year. You'll use this simplifying square roots. But you're looking for what is square root of 45 simplified. So square root of 45 is 9 and 5. 9 is 3 and 3. So I see a pair of 3's. So if I simplify this, C is equal to, the 3 comes out of the root, the 5 doesn't have anything to pair with, so it stays inside. C, the value of this hypotenuse, is 3 root 5. So again, given two pieces of information here, we can find the missing piece by doing a little bit of solving and then simplifying our square roots. Now it's your turn to try. So pause it and use the Pythagorean theorem. So if I use my Pythagorean theorem here, again, a squared plus b squared equals c squared. For reference, remember your right angle points to your hypotenuse. C is 11. Doesn't matter which side you pick as A and which side you pick as B. But in this case, I don't know what A is, but I know that B is 7, and I know C is 11. So if I go through to solve this, a squared, 7 squared is 49, 11 squared is 121. If I'm going to solve this, get A alone, I need to subtract 49, which is, I don't want to do it in my head, 72. So a squared equals 72, and now I take the square root of both sides. So the square root of 72 is 36 and 2, 36 is 6 and 6. You can keep breaking these down, but remember, it's the square, we're trying to get all the perfect squares out. So as soon as you find a pair of numbers, you can actually stop breaking them down, because now I can see that a 6 is going to leave the square root because I can take the square root of 36, and a 2 is left inside. So the answer would be simplified 6 square root 2. So that missing side, x or a in my choice there, is 6 root 2. So you can see the Pythagorean theorem is one place where radicals can be applied. The idea here is by doing 6 root 2, instead of taking the square root of 72 and saying, oh, it's 8.48528137, the point is that's an approximation. 6 square root of 2 is the exact answer. There's no rounding involved. That side is exactly 6 root 2. So we simplified the radical and gave the exact answer for it. So the Pythagorean theorem, one place we can use simplifying square roots. The second place is when it comes to finding distance, and distance between 2 points. So there's point 1 and there's point 2. There is a distance formula which I'll give you in a second, but the Pythagorean theorem is actually directly connected to the distance formula, and is more the way that I generally teach somebody to think about finding the distance between 2 points. But finding the distance is another place where you could use simplifying radicals, whether you use Pythagorean theorem or distance formula. So the first thing I want to do is put these points on the graph. And sorry, I should have pointed out that you would potentially need some graph paper here. So there's my 2 points, point 1 and point 2. So basically, I want to find, if I put a segment in here between these two, I want to find how far apart are those two values. You may be saying, okay, I'm not really seeing the Pythagorean theorem here yet. And where you're going to see the Pythagorean theorem is, think about when we do slope. We say that between the 2 points, we calculate the rise and the run. How do you calculate that rise and run? Well, you figure how far up and down did you move, and how far right and left. So we're using the grid lines. Here's my rise value. Here's my run value. If I were going to count out visually the slope, notice what else did I just make? I made a right triangle. This distance is what I'm trying to find. And if you notice on the sides of my triangle here, I can easily count out the rise value is 4, the run value is 8. So it's like the lengths of the sides on my triangle. It's like I have a triangle that is 4 on one side, 8 on the other, and I'm trying to find the hypotenuse. So the distance formula, I will give you in a second here, but again, finding the distance between 2 points, it's a lot easier to think of it as, okay, I'm just going to visually do the Pythagorean theorem. Of course, you do have to be strategic about it and use your grid lines to help you out as far as making that right triangle in there. So when it comes to the distance formula, and here's just another example, the rise is -6, so it's like this triangle is 6 on this side, the run is 2, it's like the triangle's 2 on this side. Again, we could think of Pythagorean theorem here. We could think a squared plus b squared equals c squared. The distance formula relies on this relationship, but does it kind of in a disguised manner. What you want to think about is, okay, this 6 number. How could I have gotten this 6 number? Or in other words, my a value. Well, that comes from look at your 2 points here. That comes from the 2 y coordinates. So the up and down motion, the rise motion, has to do with the y coordinates. So what would you do with those y coordinates to get the 6 or the -6, because when you square it doesn't really matter? You would be taking those 2 y coordinates, and this should look familiar from the slope formula as far as this notation. You take the y coordinate from the second point minus the y coordinate from the first point, and that's how you get the a value. How about the b value? If I say that b is 2 here, how did I get that run value? I do the same thing, but do it with the x coordinates. So again, whether that run is 2 or negative 2 doesn't really matter, because in the end, I'm going to be squaring each value. So the distance formula says take the values of the y and subtract them, take the values of the x and subtract them. Those are your distances, those are your sides on your triangle. And then that's equal to that missing value, or in other words, this is generally referred to as the distance. We'll say the distance equals. The distance formula then, the last piece is, we write it as the distance equals, so we need to take the square root of both sides to get rid of this square. So the distance formula says that distance is equal to the square root, and notice over the whole thing here, the y value subtracted, squared, plus the x values subtracted, squared. You can do the problem using Pythagorean theorem. You can do the problem using the distance formula. The distance formula you have to memorize or kind of logically think out how you get it. The Pythagorean theorem, a squared plus b squared equals c squared, something that you're much more familiar. So we're going to do two problems here. Doing the distance formula, I prefer to do the Pythagorean theorem. So if you prefer to do a different way, feel free. But I'm going to go ahead and plot my points, -4, 0, and 2, 4. And I'm trying to find this length of this segment. How long is this segment? So what I need to do is create, using my rise and run, create a right triangle here. How tall is this right triangle? Well, the rise is 4. The base of the triangle here is 6. So again, I prefer to do a squared plus b squared equals c squared. 4 squared plus 6 squared equals that missing length squared. 4 squared is 16. 6 squared is 36. That's 52 that I'm taking the square root of. And the square root of 52 is 2 and 26. 2 and 13. So I've got a pair of 2's. C equals, the distance equals. A pair of 2's came out. A 13 can't be broken down anymore. So the distance between the 2 points is 2 square root of 13. You could do the exact same thing doing x1, y1, x2, y2. It just depends on which you feel more comfortable with. For the you do, I'll show it using the distance formula. But you want to go ahead and try the you do on your own. So the distance formula says square root of, so this is x1, y1, x2, y2. Says subtract the y's, square it, and in the same order subtract the x's, square it. So this is, and whether you do Pythagorean theorem or the distance formula, you should get the same answer. -5 minus, -1 squared plus -3 minus 5 squared. So I'm going to verify to you here 5, -1, -3, -5. The numbers I get, -5 plus 1 would be -4, and notice it's in parentheses, still squared, plus -3 minus 5 would be -8 squared. If you look at my Pythagorean theorem, notice the side lengths of my triangle. 4 on this side, 8 on this side. We're still going to get those same values, the rise and the run values. Negative and negative, or positive and negative. The values may be changed as far as that goes, but when we square them, 4 squared or -4 squared is 16. Either way, -8 squared or 8 squared is still 64. So we're taking the square root of 80 for our side length, which is equal Sorry, I'd skip ahead here so you can see the final answer. The final answer, 2 2's come out, a 5 stays in. The answer for the length, 4 square root of 5. So we'll practice this in class tomorrow.